Okay, folks, our 42nd installment now, still in the topic of statistics, and we're talking about frequency tables and histograms still, and we're going to look at some review questions now, so some practice questions similar to those that we tackled in the previous section. Okay, first one, not difficult at all. If you get this on something like this on a test, you should be very happy. Which histogram represents a data set with the greatest standard deviation? So you got to remember what standard deviation is. It's a measure of dispersion. So how far out is the data set spread all over the place? Well, so we're basically looking at which one of these histograms, which we don't even have labels on, they're just sort of qualitative, looks like it's the most spread out. What I look for is, look at this down here and over here, and then down here and down here. Those three don't even spread, well, sort of due to the right, but to the left anyway, they don't spread out all the way at all. But look at this one in part C. It is way outspread that way. And not only that, but the data are not really clustered together in the middle. The rest of these all sort of come up to a very distinguishable peak in the middle. Okay, but this one down here, it doesn't. It's very flat on the top, so the data are more spread out on this one. So what we would think about with that one is, that's definitely got the most dispersion, so it's probably got the highest standard deviation. So I'm going to say part C. I think that looks reasonable here. Okay, for the next one, we actually have to go through the process of creating a histogram for a given set of data. And depending on the type of technology you're using in your class, when you get really large data sets, you'll do this that way. But for now, let's just run through. It's not all that difficult to do anyway. So let's pick on, see if we can find all the numbers that are in the 50s here. So we got 1, 2, and I think that's it. I don't see any other numbers in the 50s, so we got 2 of those. And then we'll go for the 60s. I got 1, 2, 3, 4, and I guess that's it. 1, 2, 3, 4. So 4 numbers in the 60s. Then in the 70s, we have 1, 2, 3, 4, 5 of those. So if you were keeping a running tally, you'd have this written down, and then you'd say, okay, I got 5 in the 70s. And then in the 80s, we have 1, 2, 3, 4, 5, 6, 7. Wow, that's a whopping big one. 1, 2, 3, 4, 5, 6, 7. So we get 7 numbers in the 80s. And the very last 2 that we have here are in the 90s, and there's just 2 of those. So we got 2 in the 90s. So if we're going to actually draw this histogram, our first bar in the 50s has to have a height of 2. And yes, you get to witness my wonderful artwork yet again. Okay, so that one's not so bad. I should use a ruler, I guess. And the next one we have a height of 4 in the 60s, so we're going to go up this high. And over here it'll go up that high as well. So there we are. And then in the 70s we've got to go to a height of 5. And it looks like we're going to have to extend beyond the reaches of this predetermined graph here for those numbers in the 80s, because we had 7 of them. So we'll say 6 and 7 will take us all the way up there. So we'll have to go up to 7 for the 80s, thusly, and unless I miscounted. And then for the 90s, we had just 2 of them, so that'll take us right here. Let's double check that count on the 80s. Were there really 7 80s? See, 1, 2, 3, 4, 5, 6, 7. There sure were. Wow. Okay, so there's a rough idea. Your histogram, so from your histogram you could estimate that your mean would be somewhere in here, I don't know, 75-ish. Not terribly spread out, so your dispersion here is not too ridiculous. Okay, so let's take a quick look at just a summary of the things that we talked about. Create a frequency table by choosing bins and organizing our data. Frequency tables can be used to create histograms. And we should probably go back there. I'm just going to jump back for one quick second and put a frequency polygon on this too, just so that we remember that that is a thing that we have to know about. So we have frequency polygons by playing connect the dots with all of these. So we connect all these up and we get what we call a frequency polygon to give us an idea of the shape of the data set. Okay, so that's pretty much it. So hopefully that's helpful, and we'll see you in the next session.